Hey everyone, this is Mrs. Bogus, and I am going to be talking to you today a little bit about identifying the graphs of trig functions and their key features. So I've included some cool dance moves, and we're going to talk about the highs and lows of math. So an overview, excuse me, of this presentation is going to be that we are going to review graphing sine and cosine, and then we're going to talk about how we identify the different transformations in graphs. So hopefully you have your notes with you and you are able to reference those or take your own notes as I walk through this presentation. Feel free to pause at any time or go back to anything you need to. So hopefully by now you are aware of how to graph this sine graph. We're going to show cosine next. But the two big things that I want to point out here are the axes and kind of those 5 main points. So you can see that on our y-axis, we're only going from -1 to +1, and that's huge. And on our x-axis, we are only going to 2 pi. And if you remember stuff about the unit circle, that's a full distance around the unit circle. Additionally, we can see that there are 5 main points that we're talking about. The 3 points that are directly on the x-axis, and then 1 above, 1 below. So that might be some way that you can remember this. Here's the cosine graph. Same thing in terms of the axes. On the y-axis, which is over here, we are going from -1 to +1. Only with cosine, you can see that we're starting at 1. Whereas with sine, we were starting at 0. And again, we've got our 5 points, 2 points that are at the maximum, 1 in the middle at the minimum, and then those 2 that are right on the x-axis. So if you know one, it's pretty easy to know the other one. Remember that this is a really important skill that you need to know for this specific unit. So you guys hopefully have completed the Desmos activity where you were tinkering around with sliders and the graph was changing. So we're going to talk today about what A, B, and C, what those specific values actually do to our graphs. Here are the two graphs together that you can see them. So I wanted you to be able to see those so you could see how they were different. Sine is in red and cosine is in blue. So think back to in Desmos, you should have some notes that say what you think the A value actually did to the graph. So remember what that actually did to the graph and what your conjecture was. And here's what it actually is doing. So the A value is the amplitude, and the amplitude tells us how tall our graph is. And it starts at the midline. That's what's really important. So you can see here that we're starting at 0 and our amplitude is 6 because our highest point is 6 from the midline and our lowest point is 6 below the midline. So I would say on this graph, the amplitude is 6. Next, we're going to talk about that C value. And if you look back at your notes and kind of figure out what happens with the C value. And the C value changes our midline. So the graph that I'm showing you up here has no changes except that last number, that C value, moved the graph down to -5. So our amplitude comes from the midline. So really the midline would be the first thing that you'd want to try to identify in a graph, and then you would go from there with the amplitude. So in this situation, our midline is at -5, right in the middle of the graph. And our amplitude would be 1 because we can move up 1 and below 1 to get to that maximum and minimum points. So in this graph, I'd like you to pause it and identify what the amplitude and midline would be. Hopefully you said that the amplitude was 3 and the midline is at +4. If you have any questions, please let me know. So we're also going to be talking about the domain and range, and like I have on your note sheet, this is actually really easy. The domain will always be the same number, and that's going to be all real numbers. Since domain is talking about all of the possible x values that we could input, That's what's going to give us any number that we want to put on the x value. We will have an output. The range is going to be our y values, and that is just going to be the highest point on our graph and the lowest point on our graph. So in this situation, our range would be 1 is less than or equal to y is less than or equal to 7. And I'm not going to be picky about how you let me know that. However you choose to write that is fine by me. So now we're going to talk about period. I need to give you some background information on that before we talk about how that actually changes the graph. So we're going to talk about functions being periodic if their patterns repeat. So if we see something that is kind of up, down, up, down, up, down, we would call that periodic. So when we're talking about the period, the length of one cycle, so an up, a down, and back up again, that's called the period. So in this situation, this graph right here, you can see that our period is going to be at 6. It's going to just be 6. It's the length. Because we're starting at 0, we would go down, back up, and then we hit our original y value for one complete cycle at a length of 6. So in looking at these two graphs, we would see that the two on the right are going to be periodic because they are repeating outputs and they are in a cyclical manner. The one all the way to the left, this is not going to be periodic because the y values aren't repeating. So yes, it is going up and down, but you can see that this graph all the way up here, we don't hit that point ever again. So it is not periodic. So let's look at what the period would be here. So we'll start with our amplitude. Our amplitude is going to be 2. We are going up 2 and down 2 from our midline. And the midline is just going to be right here at 0. That's halfway between the graph. And so now when we talk about period, that's going to tell us we want to know how long is one cycle. So in this graph, you can see that I have completed one cycle in pi. So that is the period. Let's look at this one. I'll give you a minute to look and figure it out on your own. Be careful of the axes too. Okay, so hopefully you've seen that the midline is going to be actually at 2 because each one of these is 2, 4, 6, 8, 10. So the midline is at 2. The amplitude is 1 because we're just going halfway up and halfway down. And the period is actually 8 pi. We don't repeat our graph again until we get to 8 pi. So that would be the period. So that is our b value. Our b value is the period, and we're not going to be dealing with looking at things from an equation, so it's kind of an irrelevant thing. You just need to be able to look at it from the graph, but I wanted to address that with you. So why don't you take a minute and look at this graph. This is going to be kind of a final review, and then I'll give you some practice to see if you can identify the amplitude, the period, the midline, and then the domain and range. Okay, the amplitude, well, let's start with the midline. The midline is going to be at -1. That's going to be this middle part right here of the graph. And so from there, our amplitude is 3 because we're going up 3 and we're going down 3. The period is going to be pi over 2 because you can see we start here at 0 and we go up, we come back down, and then we return to our starting value at pi over 2. The domain is always going to be all real numbers, and our range is -4 less than or equal to y less than or equal to 2. And I thought this graph was funny, so I wanted to include it, and it kind of looks like what we're doing. So now come find me, see if you can get some practice in, and then you will be ready for your quiz. Thanks so much.